Hey there, aspiring developers. Today we're going to explore a fascinating piece of code that captures the essence of creating a server endpoint with ExpressJS in Node.js. This isn't just any endpoint. It's designed to handle HTTPS post requests, which are a cornerstone of web development, especially when it comes to forms and data submission on the internet. Imagine you're building a contact form on a website, and you want to gather some essential information from your users, like their first name, last name, email, and telephone number. Our code example does exactly that. It receives this data through a post request, validates it to ensure everything is in tip-top shape, and then pretends to save it to a database. It's like creating a digital mailbox that not only checks if every letter is properly addressed, but also makes sure they're filled out correctly before storing them away. But there's more. We've added a layer of security with an XAPI key header check. This ensures that only those with the correct key can use our endpoint, keeping our digital mailbox safe from unwanted mail or spam. It's a great way to introduce you to the concept of API security and why it's crucial for any web service you'll create. This piece of code is not just useful, it's a foundational skill set wrapped in a practical example. Learning how to handle post requests, validate data, work with headers for authentication, and simulate database interactions are all critical skills for a budding web developer. These are the tools that will allow you to build robust, efficient, and secure web applications. Now let's dive into the code and see how all these pieces come together to form a fully functional endpoint in an ExpressJS server. Let's break down the ExpressJS server endpoint code piece by piece, diving deep into each section to understand its role and how it contributes to the overall functionality. This tutorial assumes a basic understanding of JavaScript and Node.js concepts. The journey begins with importing the Express framework and initializing it by calling Express. This framework is the backbone of our server, providing a robust set of features to handle HTTP requests with ease. We also bring in body parser, a middleware necessary for parsing incoming request bodies. In the context of our code, it's crucial for extracting JSON data sent through post requests. By using body parser, we tell our Express app to automatically parse JSON formatted request bodies, making the data easily accessible via the request body. Before delving into request handling, we define a fictional function, write-to-database, which simulates saving data to a database. While this function merely logs the data to the console in our example, it represents where you would include logic to interact with a real database. This step is about preparing for data persistence, emphasizing the importance of storing user inputs securely and efficiently. Security is paramount, and we address this by creating middleware to validate an XAPI key header. This function checks if the incoming request contains a specific header with a correct key. If not, it sends back a 302 error, effectively blocking unauthorized access. This middleware showcases how to protect endpoints from unauthorized use, a critical aspect of building secure applications. Data validation is another critical step. We introduce a function that uses regular expressions to validate the format of email addresses and telephone numbers. This ensures that the data conforms to expected patterns, reducing the chance of incorrect or malicious data entering the system. It's a demonstration of how server-side validation can safeguard your application against common data input issues. Now, we reach the core functionality, the post request handler. This part of the code sets up an endpoint that listens for post requests. It uses the previously defined API key validation middleware to secure the endpoint. Within the handler, we extract and validate user inputs. If any field is missing or doesn't meet our validation criteria, we respond with appropriate error messages. This teaches the importance of validating and sanitizing user inputs to maintain data integrity and provide clear feedback. Assuming all validations pass, we simulate a database write operation by calling our placeholder write-to-database function. This part illustrates how to process and store validated data. Finally, we send a success response back to the client, signaling the successful handling of their request. This step completes the request response cycle, highlighting the importance of feedback in user interactions. The last piece of the puzzle is booting up the server. We specify a port and use the app.listen method to make our Express app start listening for incoming requests on that port. This is where our server becomes live, ready to handle requests based on the routes and middleware we've defined. Each step in this tutorial builds upon the last, starting from setting up the server environment, through securing and processing requests, to interacting with a database, albeit simulated. By understanding each part, developers can grasp how to build secure, efficient, and responsive web applications using Node.js and Express. As we wrap up our journey through creating and understanding this ExpressJS server endpoint, it's important to recognize how such a piece of code fits into the larger picture of web development. This example, while simple, lays the groundwork for what is possible when building web applications with JavaScript technologies. It serves as a microcosm of the server-side logic that powers complex applications, handling data securely and efficiently. The concepts we've explored, including API key authentication, data validation, and interaction with a database, are foundational. In a more extensive application, you could extend this endpoint to handle more sophisticated data structures, integrate with real databases like MongoDB or PostgreSQL, and serve as a backend for user registration forms, contact pages, or even dynamic web applications that require user input. Reusability is another critical aspect highlighted by our code. The validation functions, API key middleware, and the structure of handling a post request can be adapted and reused across different endpoints, promoting dry, don't repeat yourself principles. This not only speeds up development, but also ensures consistency and reliability across your application. Efficiency, both in terms of performance and development time, is at the heart of using JavaScript and Node.js for web development. Node.js's non-blocking I/O and the event-driven model allows for handling numerous connections simultaneously, making our simple endpoint scalable. Furthermore, JavaScript's ubiquity, running both on the client and server side, streamlines the development process, allowing for shared knowledge and code bases between the front end and back end. In the context of a bigger application, the principles we've discussed can be expanded upon to build robust, secure, and user-friendly web services. Whether it's adding more complex user authentication, integrating third-party services, or scaling to handle thousands of requests, the foundation is the same. It's about understanding the core concepts, applying them effectively, and continuously learning to leverage new technologies and patterns as they emerge. Thanks for watching, everyone, and don't worry if you missed anything. We've added a link to the source code in the description. If you found this video to be helpful, please like and subscribe for more of the same. Thanks again, and remember, we're always learning, so keep coding, keep exploring, and keep building amazing web applications.